Welcome to Easy BTech, your guide for BTech and beyond. In this today's lecture, we will discuss the importance of alpha beta gamma relationship. Okay, students, so we will start it. Okay, we already know that. We know that transistor has three terminals. Transistor has three terminals. That is, number one is emitter. Second one is base. Third one is collector. Okay. Now, from these parameters, we are having alpha, beta, and gamma. Alpha is nothing but this will represent in two cases the current gain factor for common base configuration. Beta is a current gain factor for common emitter configuration. Gamma is a current gain factor for common collector configuration. Okay, this is the alpha, beta, and gamma. What is the difference? Suppose you can take alpha in common base. Alpha are of two types, that is DC supply and AC supply. For alpha DC we can represent output current. That is, for common base, the output current is, suppose for a common base, it is base is common because BJT is a two-port network. I can say base is common. Common base means base is common. It is emitter, it is base, it is collector. Now here, if you take NPN transistor, now you can say base is common between it is an input and it is an output. For a common base is grounded, base is common between input and output. Then we can write output current is output terminal is collector, input current is IE emitter. Now we can write alpha DC is nothing but output current by input current. Input current is IE. Similarly, IAC is nothing but change in IC by change in IE. This is as the common is, the base is made common. Similarly, if common emitter is common, now we will represent like this. This base, it is collector, it is emitter. So emitter is common, it is input, it is output. Here output you are having collector IC, input you are having base current IC. Now beta is a factor for common emitter. We will represent beta DC by beta AC. You write output current is IC by IB. Here we can write change in IC by change in IB. Similarly, common collector. Collector is grounded, that is gamma. This is a gamma. Gamma means collector is grounded. This input, this output. Output is emitter. This is IE. This is base IE. Now we will write a gamma DC is equal to, we will write output IE by IB. Change in IE by change in IB. Okay. Now you remember this three important factors. Alpha is equal to output current IC by IB, IE. Beta is equal to IC by IB for DC. For gamma is equal to IE by IB. You can remember these factors. These are the current gain factor. Alpha, beta, gamma. For common base, it is common base, it is common emitter, it is common collector. Now students, from this we will write as it is emitter, it is base, it is collector. Now we know the transistor action. Emitter, current can flow from emitter to collector. That is a transistor action. Now the current exists. Therefore, the current exists in the transistor. That we will write as an IE is equal to IB plus IC for NPN transistor. IE is equal to the total current. IE is equal to IB plus IC. Now you can take IE is equal to IB plus IC. Let's assume as an equation. Now divide equation 1 with respect to IE. Then what you will getting? IE by IE is equal to IB by IE plus IC by IE. Now you can get here IE it is 1 is equal to IB by IE. IB by IE. Now we will write gamma is equal to output current is IE, input current is IB. This we will write as IE by IB can be written as gamma, and IB by IE can be represented as 1 by gamma, plus IC by IE, output current is IC, input current is IE. This we will represent as an output. From this, you can write 1 minus alpha is equal to 1 by gamma. If gamma is equal to 1 by 1 minus alpha. Okay students, you can remember the gamma in terms of alpha. Gamma in terms of alpha is equal to 1 by 1 minus alpha. Similarly, The same manner, you can take equation IE is equal to IB plus IC. Now this you can divide by IB. This equation you can divide it by IB, then what you will getting? IE by IB is equal to IB by IB plus IC by IB. Now you can write IE by IB as a gamma. Gamma is equal to IB by IB, it will be 1 plus IC by IB, beta is equal to, this value is beta. It means you can remember gamma is equal to 1 plus beta. Gamma is equal to 1 plus beta. This is the current gamma value. Gamma in terms of alpha, gamma in terms of beta. Gamma in terms of alpha, gamma in terms of beta. In the same manner, if you want to calculate for alpha beta relationship, IE is equal to IB plus IC. Now you can divide by IC. This is an equation. Divide by IC. Then you will get IE by IC is equal to IB by IC plus IC by IC. Now you can represent here IE by IC. Now we know that gamma is equal to, for gamma output is IE, input is IB. For alpha output is IC, input is IE. Means we can write this factor as 1 by alpha. 1 by alpha is equal to this IB by IC. This IC by IB we will write as 1 by beta plus this IC by IC 1. Now from this you can find these values. If you want to find beta, 1 by alpha minus 1 is equal to 1 by beta. Now if you want to write a beta, 1 minus alpha by alpha is equal to 1 by beta. You write beta is equal to, reverse it, alpha by 1 minus alpha. This is the relationship of beta in terms of alpha. Similarly, from this factor, you know that 1 by alpha is equal to 1 by alpha is equal to 1 by beta plus 1. Now here, to find the value of alpha in terms of beta, we can write 1 by alpha is equal to 1 plus beta by beta. Now alpha is equal to beta by 1 plus beta. Alpha is equal to beta by 1 plus beta. This is the relationship. Okay, this is the alpha, beta, gamma relationship. You will see once. Therefore, alpha is equal to beta by 1 plus beta. write beta is equal to alpha by 1 minus alpha, gamma is equal to 1 by 1 minus alpha, gamma is equal to 1 plus beta. These are the 4 formulas. These are the 4 important formulas. Relationship between alpha, beta, gamma. Suppose the problem may be like this. The collector current AC is equal to 0.95 milliamperes. Find alpha, beta and gamma. Find alpha, beta and gamma when base current is 0.05 milliamps. This is the formula I have given. Now you have to find all this formula. Now to find this alpha, what is the formula for alpha? Alpha is equal to IC by output current, that is common base. It is emitter, it is collector. That is IC by IE. Okay, you know IC. What is the value of IC? 0.95 by IE. Here IE is not there, it has given the base current. Now from this you can find IE is equal to IB plus IC. Okay, now from this you can find IE is equal to, what is the value of IB? 0.05 plus 0.95. It will be 1 milliampere. Now the alpha value is 0.95. The value of alpha. Now similarly, if you want to calculate, if you know alpha, you may calculate even all the factors. That is, if you want to calculate beta, beta is equal to alpha by 1 minus alpha. Now alpha is 0.95. 1 minus alpha, 1 minus 0.95. 1 minus 0.95 is 0.95 by 0.05. You remember it is 95 by 5. Now 5 1s are 5, 5 9s are 45. 90. You will get the beta value is 90. Similarly, if you want to calculate gamma, gamma is 1 plus beta. 1 plus beta value is 90. You get 20. Like that, you can calculate the value of alpha, beta, gamma by knowing the value of this IC current, IE current, IB current, IC current. If you know these 3 currents, it is easy to find alpha, beta and gamma. Okay, students, these are the simple derivations for alpha, beta, gamma relationship. You remember this alpha value, beta value, gamma value. Okay, students, in the next lecture, we will discuss about current flow or a transistor action, BJT transistor action.